Welcome back, guys. Now, we said in the previous video that the script is used in order to save some commands and to edit them. So this roots file is saved in your documents, and you can edit anything you want on this script and then run it again, and then you'll have different answers. What if I want to take these coefficients from the user? So I don't want to define ABC here as 1, 0, minus 4. No, I want to take these coefficients from the user, and then Matlab will give me the answer. Like whenever, guys, you go to the ATM machine and you put your Visa card and you want to draw some money. Whenever you put your Visa card, the ATM machine will ask you to provide the password. This is a programming script. Whenever you put your card, the script will be run. And then whenever this ATM is asking you to provide the password, this is the input, you should put the password on the screen. If this password is correct, then you can continue your operations, and if not, this ATM machine will ask you to give another password because this password is wrong. So basically, this is a programming, or this is a script. Could be written on C++, could be written on Java, and could be written on Matlab. So this is what I'm going to do now. I'm going to ask the user to provide me ABC. How to ask the user? It is basically using a built-in function that is available inside the library of Matlab, and it is called input. So basically, I'm going to say A is equal input. Whenever you use input, Matlab will ask the user to provide, or will ask the user by a certain statement, and then the user will provide a number. This number will be saved inside the variable before the equal sign of this input, which is here A. So input, please provide the coefficient A. Don't forget the quotations, and then B as well. So what I'm going to do is to copy paste this sentence, and then here I say B, C, then this B, C. Now, guys, if you want to know, if you want to tell the user the order of ABC, what you can do is to use fprintf. Fprintf will print out any statement between quotations without asking the user to provide any variable. So fprintf quadratic equation is ax squared, or we can say this, plus bx plus c. So in this case, guys, whenever you run this code, which is called roots, first of all, Matlab will clear your command window and all the variables. And then Matlab will give you this sentence. The quadratic equation, it will be only displayed is ax squared plus bx plus c, and then Matlab will ask you to provide a, to provide b, and to provide c. And then Matlab will calculate delta, will calculate x1, will calculate x2. So I will remove the sentence, and then I will run it. Okay, so let's see what happens in the command window. So first of all, Matlab has displayed the sentence. The quadratic equation is ax squared plus bx plus c. And then Matlab is printing this sentence, please provide the variable or the coefficient a, without any enter here or space. So what I should do is to put a backslash n after each statement. Backslash n means you should go to next line. Backslash n before the quotation, remember, backslash n, then backslash n. Alright, and then guys, I'm gonna run it. Now, as you can see, guys, here that Matlab didn't run this code again another time, because in fact, Matlab is waiting from you the variable a. So in order to stop execution, only if you use input, you should stop the execution before running another script or another modified script. So how to stop this execution? You should click on Ctrl C, like copy in Word, Ctrl C, and then Matlab will stop this execution. So since I click on run several times, this is what happens, then I will CLC. Let's run it again now. So you click on Ctrl C until you see these two arrows, and then you run it again. So here what happens is that Matlab is giving me this first sentence, and then Matlab is saying, please provide the coefficient a. So what I'm going to do is to provide this a, which is, let's say, 1. Please provide the coefficient b. So what I'm going to do is to provide this to b, let's say it is -4, and then I will click enter. Please provide the coefficient c, let's say it is also 1, and then I will click enter, and then as you can see, all your x1, x2, delta, ABC are shown in your workspace. So guys, if you want to run it again for different inputs, what you should do is to wait for these two arrows to be displayed in your command window, and then you can run it again. Now again, please provide the coefficient a, let's say it is 4, b is 0, c is 4 or -4. Okay, so as you can see here, guys, x1 and x2 are displayed. Now, what you should know, guys, that even if they are complex, Matlab will give me the answer. So let's do one complex number, run. Please provide a, let's say 4, 0, 4, and then as you can see, x1 will be I and x2 will be -I. So guys, this is what is a script, and this is what differs a script from the command window. So here, guys, I'm using the script, I'm receiving my inputs from the command window, and my outputs will be shown in the workspace. If you want to show them in your command window, of course you can, but what you should do is either to remove the semicolon and run it. Let's say 4, 0, -1, and then this x1 and x2. Or you can use also fprintf to show these two variables, but I'm not going into this fprintf now because it needs some formatted output and input. So let's stick now to the script. So this is how the script could be done, and you can, guys, go to the files and the resources and do other examples. So here, for example, this is an example of the draft that we're gonna do in the lab part in the next video. And also you can have other scripts that you can do, like for example, to find the moment of inertia, the area, and the moment of inertia of different shapes. I'm gonna do only one, and you can do other shapes, all right? So let's do one. How to open a new script? It is only either to click here on new script, or to click on this positive sign here. So I'm gonna click on this positive sign here, and then what I should do is to find the area and the moment of inertia around x and y for this rectangular shape. Alright, so what I'm going to do is first of all define the dimensions that are b and h. Alright, so first of all, of course, start with CLC and clear all. Guys, question, why I can here start by CLC before clear all? Because in fact this is a script, not a command window. So if you write here in the script CLC and the clear all, you will not see clear all in your command window like the case, like the previous case where you wrote the CLC and clear all commands on the command window. So here in the script, this is separated from the command window, so you'll not see anything in your command window, even if you write here CLC before clear all. Alright, so first of all, I'm gonna ask the user to provide, let's say, B. Alright, B is equal to input. Please provide the base \n, close the quotations. And then H is equal input please provide the height \n, close. Alright, and now of course A will be just the area, B times H, so you can add here for your information percentage. This is the area, and of course ICX, which is the moment of inertia around S, will be BH cubed over 12. Then ICY will be HB cubed over 12. So that's it, guys. This is how you can write a script. Of course, you can run it before writing A, ICX, ICY, or you can write all your script and then run it and then explore what are the errors if there is any. Alright, so I'm gonna run it now, and of course, I have a lot of similar scripts, so I'm gonna call this moment of inertia rectangle. As long as there is no space, I can put underscore, by the way. As long as there is no space, I can run this. Then here, please provide the base, let's say it is 12. Please provide the height, let's say it is 3. And then here you can see A, ICX, and ICY. Thank you.